In this video we're going to look at the role of secondary storage in computer science. First things first, I just want to go through some basic terminology. So a backing store is a device that is used to store files and programs permanently. So it's what when you install a game or something like that and it stores it to your C drive, that is your backing store. I don't mean the programs stored in RAM. A mass storage device is a backing store that is capable of holding large numbers of files. Secondary storage in general refers to a mass storage device that cannot be directly accessed by a CPU. So we have to transfer that information to the RAM before it can be used. So when you open up your game to play it, it then copies parts of the program you need into RAM for you to use. And offline storage refers to a subset of secondary storage devices that are not always available. A USB flash drive. Storage media refers to the way data is stored on a device, such as magnetically, optically, or solid state. Storage medium refers to the devices itself, such as a hard disk drive. And data access time is the time it takes to find a specific file or record, which is measured in milliseconds. And data transfer rate is the speed at which data can be read or written, and this is measured in bits per second or BPS. Storage capacity refers to the amount of data that a device can hold, and this is measured in megabytes, bytes, kilobytes, gigabytes, terabytes. And 1 byte refers to 8 bits of binary. An important fact is, regardless of medium and type, all secondary storage is slower than RAM and ROM and significantly slower than a CPU. So you've got a bit, which is 1 binary number, you've got a nibble, which is 4 bits, you've got a byte, which is 8 bits, and then you've got a kilobyte, which is 1000 bytes, megabyte, which is 1,000,000 bytes, 1,000,000,000 bytes, and so on. So storage mediums. Secondary storage devices are used to save files that we've created on our computers. Now, one thing that we need to clear up is that what a lot of people talk about is they say, oh right, secondary storage, well, your main hard drive must be primary, secondary storage is like a backup. That's not true. Secondary storage are all the files that we save our documents onto, or music, or games, things like that. So they're all backing stores. Even a backup drive you've got is still a secondary storage device, as much as your primary hard drive is. Now, secondary storage is non-volatile. What volatile means is when it is not being powered or it's not got electrical current, it will forget what's stored in it. So secondary storage, even when your computer's turned off, remembers everything. Therefore, it is non-volatile. And there are 3 mediums of storage device. You've got magnetic storage, optical storage, and solid state. And sometimes we also throw in cloud storage as well, as that's becoming more popular in the modern age. Now we've got 3 ways of accessing data. So we've got serial, where data stored in the serial file is stored in the order in which they were added. So if you do one thing on Monday, Tuesday, Wednesday, Thursday, it'll go in that order, it won't go in like a random order. So when a new piece of data is added, it just gets appended to the end of the file, and each record must be then read in that order. Now, sequential is where records within a file are stored in a particular order based on some form of key field, so it follows a sequence that's like preset. And then direct is where records can be accessed in any order, because we can use a key field within the record to calculate its address. So let's look at optical first. So this type of storage uses light, usually some form of laser, to reflect off a shiny disk. Now, the disk has marks and grooves that are burned into the disk, and these reflect differently to an area without a mark, so they can be read by a laser. So essentially, if the light gets reflected, it could be a 1, and if it doesn't get reflected, it could be a 0, and it's all stored as binary. So the CDs, DVDs, and Blu-rays. Now, as I've said, we use laser beams to read optical storage. So we've got a CD-ROM, which is read-only, and that's like the smallest. You've got a CD read and write, so RW, which is slightly bigger. A Blu-ray disc is the biggest, and DVDs store quite a lot, but Blu-ray is your largest one, and your CD-ROM is your smallest. Now, storage in the cloud is usually a big massive factory with loads and loads of servers in a data storage facility, which allows you to store your data on somebody else's property essentially. You can then access that data from many computing devices. Now the good thing about that is that it's great for backing up. I personally have a cloud storage service where I've got all my lessons that I've ever taught, I've got all my videos that I make for YouTube, I've got pieces of software that I've used, like freeware and things that I want to be able to use on multiple computers. I've got lots and lots of stuff stored. It also means as well, if you run out of space, or say at home, like this laptop I've got right now doesn't have much space. I've got 256GB SD card, as well as I think I've got about the same just general storage. If I run out of that, I've got to then go buy a bigger SD card. Whereas if the cloud servers run out of space, it's their responsibility to go ahead and get some more space. However, the disadvantages are that you need an internet connection. It also might be stored in, say if you've got your cloud storage stored in China and you're from England, they're not going to use GDPR, they're going to have data protection laws, or they might not have ones that are as good, so they could be selling the data or not having any protection in place to look after it. Whereas if you're a European and you're in the EU, GDPR protects your data from being moved around, being sold and being used. And you are completely reliant on a storage cloud provider, which is a bad thing and a good thing. If their data center blows up and you lose all your data, then you're sort of at their mercy. But at the same time as well, they're responsible if they lose your data as well, so you've got a little bit of protection there. Now next one we'll look at is solid state storage. So this is called solid state as it does not have any moving parts. If you think about optical, that's got a spinning disk, it's moving all the time. Now solid state storage technology is increasingly used to replace magnetic and optical, especially in mobile devices. They use a grid of electrical cells to quickly send and receive data, so solid state drives and USB sticks, SD cards, things like that. Now SSDs are a lot faster, so even if you don't use it for all your storage, on my old PC I used to have a solid state drive, just my operating system and the games I played the most, and then everything else on a hard drive. That meant that my computer booted up really quickly. So solid state, a bit more detail, uses what's called flash memory. So flash memory stores data by using a series of transistors that can be switched off or on by electricity. Now these transistors retain their state even when the power's off, which means it's not volatile. So you might think, oh right, look here, it's got some chips just like RAM does, it means it must be volatile. The way they're built is that they are non-volatile. So we've got SSDs, SD cards, USB drives. Next we'll look at magnetics. So there's another one that moves. So we use magnets to make different patterns of magnetization on the disk. Okay. Now a read-write head, which is this bit here, is used to create and read the marks. So we've got hard disks, floppy disks, and magnetic tape. So as I've said, it's stored on a magnetic disk. It can be a disk or tape by using data on a read-write head. The data can be then read by the read head, and it has positives, which are ones, and negatives, zeros. So some more tape. We've got tape drives, hard drives, and hybrid drives. So a hard disk drive it's not just one single magnetic disk, it's got lots of them on top of each other, and they're called platters. Now each of these platters still has the same magnetic material, and then the read-write arm is actually loads in a sort of stack almost that reads all of the platters, or it can access all the platters. So when we want to access a specific file, then we spin the platter and move the arm to that platter and then begin the operation. Now hard drives are excellent for real-time access because they use a direct access method, which means they can get any file any place, so they don't have to go through all the files. Now they're pretty fast, they're pretty decent. Everyone sort of slates hard disk drives saying, oh, they're rubbish now because you can get solid state, but they are still a decent time. It's not that awful, but it can be affected by how many separate files they've got, how fragmented the disk is, and if you're trying to access lots of files at once. So you see we've got the platters, so there's lots of these. You see there's multiple there. You've got most that spins, the read-write head, and then the actuator which actually sort of moves it, and then the interface is where you plug them in, and essentially you have a big ribbon cable goes in there, power supply and things like that. So these get plugged into your motherboard, and then you put it in a little shelf inside your case, and then it should just work. So these things here are what are called tracks, and these are sectors, and we'll talk about those in a second. So what you can get in hard drives is things called a bad sector. Now sometimes hard disks, optical disks and solid state mediums can report having a bad sector. Now what this is where there's some physical damage on one of the chips, in a SSD's case, or on one of the sectors. So unless you've already backed everything up, you're going to lose that data. Now in the future, what they'll do is they'll see the sector, say, right, this is a bad sector, can't use that, and it will skip it, which means you can't use part of your hard drive, so you're actually losing capacity. So I've got a little comparison table. So your optical is your slowest, but it's very durable. So if you drop a CD, unless you're really inaccurate, you drop off a big building, it should be fine. It's also portable, light and cheap, but you can't really get a high storage capacity. Now magnetic is like a medium speed, but if any of the moving parts get damaged, it's not going to work. They're not as portable because they're quite heavy and bulky, but you can get very large sizes. Solid state is very fast, but can have a limited number of read and writes. They're very durable, as they're all fixed in place, nothing really moves around. They're small and light, but at the minute they're really expensive per gigabyte. So you can get, you know, a 1 terabyte solid state drive, but it's going to cost you a lot more money than a 1 terabyte magnetic drive. And in cloud, the speed depends on how good your internet connection is. It's got the best durability because you can't drop it or anything like that. It's very portable, and it can be very, very large. You just have to pay per gigabyte, so it can get more expensive. And hopefully that was nice and informative, and you understood everything that's going on, and you know everything about secondary storage. And I'll see you in the next video.